Okay, so this is my third time making this video. I've made a few mistakes. Unfortunately, this video took like 10 to 15 minutes. So here I go again. So in this lesson, we will calculate inscribed angles and intercepted arc like measures, right? So in order to do that, we first need to understand what inscribed angle is, what an intercepted arc is. So we have a circle. We can see that this angle created by these two rays touches the circle at one point here, one point here, one point here. This angle here is called the inscribed angle. Now, when it intercepts the circle, this creates an intercepted arc. So this is our intercepted arc. Easy enough. Oops. All right. So let's say we have an inscribed angle, A, B, C. Let's say it's 30 degrees. That means the associated intercepted arc is 60 degrees. So if this inscribed angle is x, the intercepted arc is 2x. Now the other way around, if you divide by 2 or multiply by half, if you multiply by 2 or divide, let me say that one more time. If you take the intercepted arc and you divide it by 2 or multiply by half, you will get the inscribed angle. So this should be easy. Find the measure of the inscribed angle or the intercepted arc. So this gives us an intercepted arc. So to get back to the inscribed angle, we just divide by 2 and we get 50 degrees. Angle N, MP is 50 degrees. This time it gave us, on the second one, it gave us this inscribed angle. So this arc that it's showing, arc ZWX, is going to be twice as large. So it is 210 degrees. Easy enough. So let's say we have a circle. Let's say we create a triangle using a point on the circle and the diameter. This is the diameter, this is the diameter, this is the diameter. Now, if this is the diameter, that means this is 180 degrees. That means this arc is 180 degrees. That means this arc, or the arc that would have been there, is 180 degrees. Now remember, this arc, this intercepted arc, will be twice as much as that angle. So if we divide by 2, we get 90 degrees. Divide by 2, we get 90 degrees. No matter where we put this, like point, this corner of the triangle, this will always be 180 degrees. So the angle that opens up to it, there, or there, or there, will be 90 degrees. So if we look here, we can just use this. So this is the diameter. That means x is 90 degrees. And we know angle sum would of the angles of a triangle will be 180. So you just take 180 and you take away 50, you get 130, and then you take away the 90 that we had from right here. And what you have, 40 degrees. Now let's check it just to make sure. We have 50 degrees, 40 degrees, and 90 degrees. So that's 90 degrees plus that 90 degrees gives us 180. So that's correct. So y is 40 degrees. Easy enough. All right, so this one might get a little crowded. But let's say we have angle ADC. I'm going to give you angle ADC. I'm going to give you angle ADC. Let's say this is 80 degrees. 80 degrees. And that means this angle, this arc right here, remember, it's twice as much. So this has to be 160 degrees. So arc ABC is 160 degrees. It's fine so far. So if that's 160 degrees, then arc ADC has to be the remaining part. So you take 360 degrees all the way around, and you take away 160 degrees, which is ABC, this arc, you get 200 degrees. So ADC right here is 200 degrees, which makes sense because 200 degrees plus 160 degrees gets you 180 degrees. Now remember though, that this arc is going to be twice as much as the inscribed angle. So if we divide by 2, we get 100 degrees. So angle ABC is 100 degrees. Easy enough. Now, I'm going to give you another angle. Let's say this BAD, so angle BAD, is 110 degrees. It looks about that. It's a little larger than 90 degrees, right? So we have 180 degrees. That means this arc, so BAD is 110 degrees. That means this arc, remember, intercepted arc is twice as much. So that has to be 220 degrees because 110 times 2 is 220 degrees. So that's arc BCD is 220 degrees. Now, if we know that this is 220 degrees, then what about angle BAD? Arc BAD, BAD. That means this part, if this is 220, that means this part right here is going to be 360, subtract 220 degrees, 140 degrees. So if this is 140 degrees, then the angle, the inscribed angle, is half as much. So 100, so that's BCD. So angle BCD is, this angle right here is going to be half of this. So 140 divided by 2, and we get 70 degrees. So 70 degrees. Not that you can see it, but you get it. But if you notice, this 80 and this 100, well, first, yeah, give you 180. This 110 and 70 give you 180. Makes sense because all of these angles need to add up to 360 degrees. But what we're basically getting at is that these opposite inscribed angles add up to, well, they're supplementary, but in our terms, we'll just say they add up to 180 degrees. Make that a little nicer, so that 8's a little weird, but y'all are used to that. 180 degrees. 180 degrees, 180 degrees, together they add up to 360 degrees. All right, almost done. So we know that these two add up to 180. 180 minus 120 is 60 degrees. Y is 60 degrees. We can take 360 and subtract these three to get that. But let's try it the other way. So those two are supplementary. So 180 minus 80 gives you 100 degrees. If we want to check our work, all we say is 100 plus 80, 180, 120 plus 60, 180, 180, 180 is 360, which is the total sum of a quadrilateral, like interior angles. Let's say you have something like this, though. Well, we know that opposite inscribed angles of a quadrilateral are supplementary. So we know that if we take them, their sum is 180 degrees. Now, the parentheses don't matter in this case because we're not multiplying anything there. So let's combine like terms. 2x, 4x is 6x, plus 3 is plus 6. So we get equals 180. Now let's take away our 6. 172. Last step here is divide by 6. We're going to get a repeating decimal, so 28.6 repeating. Alright, so if you want to know, if it asks you for this angle right here, then you just substitute that in for x. If it asks for that angle, substitute that in for x. If it asks for that angle, you substitute it in for x. If you want to know this angle, you would just take 360 and you would take away that angle, and that angle. Alright, thank you.